So we're going to start with chapter 5, section 6. Proving triangles are congruent by ASA, angle, side angle, or AAS, angle, angle. First, we're going to start with the warm-up. So for question 1, we have two triangles, and they tell us that this side is congruent with this side, and that this side is congruent with this side. Now, I don't know if you guys remember the reflective property, but it will tell us that this internal side is congruent. So for question 1, there is enough information to prove that the triangle is congruent by the side congruence theorem. For the HL theorems, hypotenuse leg theorem, we have to have congruent the hypotenuse in one leg, and it has to be a 90-degree triangle. So if we look at question 2, the hypotenuse is always across the 90 degree. So they're telling us that this hypotenuse is congruent to this, and that this leg is congruent to this one. Now, because in this triangle is not in the hypotenuse, this is not enough information to prove it's congruent, neither by the side or by the HL theorem. Now, for number 3, they tell us this leg is congruent with this leg. Again, the reflexive property would tell us that that line is congruent. So that line is congruent to itself. So I'm just going to highlight it in red. And we have that this is the hypotenuse of this triangle, and this is also the hypotenuse of that triangle. So because the hypotenuse is congruent in both triangles, and we have a leg that's congruent on both triangles, and it's a right triangle, we can say that yes, for number 3, we have enough information, and it's congruent by the HL theorem, so the hypotenuse leg theorem. So I have filled out the blank, and is if two triangles and the included side of one triangle are congruent to two angles and the included side of a second triangle, then the two triangles are congruent. What does that mean? This is angle, side angle. It has to go in that same order. So two angles of different triangles have to be congruent. Then right next to it, a side for both triangles, and then afterwards another angle. If you guys notice, we have, let's say, angle A and angle D are congruent. They give it to us with that tick mark. And then right next to it is this side that is congruent with this side. And then right after, we have the second angle that's congruent to the second angle. That is the only way that congruence postulate works. It's angle, side angle, and it has to be in that order for any triangle. So we can say, for example, that these two triangles, triangle ABC is congruent to triangle DEF by the angle, side angle postulate, because we just showed that the angle, the side, and the angle of both triangles are marked as congruent. So angle, side congruence theorem. If two angles and a non-included side of a triangle are congruent to two angles and the corresponding non-included side of a second triangle, then the triangles are congruent. Again, the key words right here are non-included side. Non-included side. What does that mean? If they give us the angles G and K, J and M, we have to mark that the side outside not included. So in this case, LM, HJ are not included. Therefore, that will make it true with the AAS theorem, congruence theorem. Now, if they were to have given us by any chance this GH or LK, it would also work, as the only side that is included is the GJ and KM. As long as it's not the included side, so whatever sandwich between the two angles, it would be congruent by the AAS congruence theorem. So because it gave us the outside side, we can say that triangle GHJ is congruent to the triangle KLM by the angle, side. If you guys ever forget the order of things, you can write side, angle, and it's also okay. Flipping it, but you're never gonna get a theorem that is cursing or any type of thing. So SSA is not a thing. but AAS is, okay? So this is what we have learned so far. We have learned the triangles, congruence postulates, and theorems. So we have learned 5 methods to prove that the triangles are congruent. Side, 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 angle, side. HL is only for right triangles. ASA and AAS. Remember, no SSA, and since you can write it backwards, no ASS. If you get either of those, that is completely wrong. So remember, no SSA. You can rewrite and flip them both ways. In this case, SSS is flipped as SSS, same for SAS. HL, if you write LH, it's okay. ASA flip is ASA, but you can write SAA as well, and it's okay. Now, if you just learn it one way, it's even better, because that way you don't have to remember both ways. Now, the SSS is just the 3 sides are the congruent. SAA is side, angle, sides. It's 2 sides with an included angle. HL, you need the hypotenuse and 1 leg on a right triangle. And ASA is angle, side, angle with an included side. And AAS is angle, angle, side with an excluded side. If you guys don't want to remember it's included or excluded, remember the order. If you do angle, angle, side, it's always in that order. So if you forget included or excluded, just go in the order of pick an angle or side and go in that order. Angle, angle, side, or if you start at the side, you can go side, angle, angle, and you still get the right postulate or theorem. Does that make sense? So we have these 3 examples, and the instruction is, can the triangles be proven congruent with the information given in the diagram? If so, state the theorem you would use. So for question 1, we can tell that these 2 angles are congruent because they are vertical angles. Now, you will be tempted to use the HL theorem because of the 90-degree angle. Now, it does not always work that way. In this case, the leg is not given to us, the hypotenuse is. But if we follow the order, we have angle, angle, side for both triangles, as it's angle, angle, side, angle, angle, side. Now, because it's angle, angle, side, that is one of the theorems, so these 2 triangles are congruent by the angle, angle, side. Now, if we look at problem B, the only line given to us is we could guess it's the hypotenuse based on how it's looking, but the outside lines. And also, if you guys remember the middle line as the reflexive property, we can say that ones are equal to each other. Now, they only give us 2 sides, but they don't give us absolutely anything else. And we cannot just guess. So there's not enough information to prove that these triangles are congruent. Now, for C, we have again that reflexive side line MP that's equal to each other. And they give us the 2 angles on the top and the 2 angles at the bottom. So if we follow the order, we have angle, side, angle, so ASA. And that is one of the theorems that we have learned. So it is congruent by the ASA theorem. Okay, so for question 1, if you guys notice, we have this vertical angles, do it in yellow, this vertical angles. So we can say those angles are congruent. If we go in order, we have an angle, and a side, and that is AAS. Okay, so it's angle, angle, side, because we go in the order angle, angle, and then to the side, angle, angle, and then to the side. Since that is a theorem that we have learned, the 2 triangles on A are congruent by angle, angle, side. So for B, guys, I don't know if you noticed, they give us an angle right here. They give us a second angle right here. And they give us a third angle right here. So what we have as written that's equal is the angle, angle, angle. So because this is not a theorem we have seen, this is not enough information to know that these 2 triangles are congruent. So B is not enough information. And for the last one, we also know that this is the reflective side, so we can say that that side is congruent. They give us two angles. For both triangles, we have angle with this angle and then this other angle with this other angle. So if we go in order for both triangles, we have angle, side, angle, and that is a theorem we have seen. So for C, those two triangles are congruent by the angle, side, angle theorem. So they want us to identify the postulate or theorem that proves that triangles are congruent. Now, instead of giving you little tick marks or congruent marks, they give you the angles. So because they give you the angles and they tell you that this one is 15, this one is 15, this one's 150, and that one's 150, if we go in order, that is angle, side, angle. Now for the other one, they tell us this is 90 for number 2. So because it's a 90-degree triangle, you guys can start thinking about HL. Obviously, anything else would work. Now we have the hypotenuse for both. We have a leg for both right here. Because we have a leg and the hypotenuse and it's a 90-degree triangle, we can say that is proven congruent by the HL theorem. And lastly, we have that it's given two angles and two sides, but the angle is not included unless you realize that these are vertical angles. Because they are vertical angles, we can say those angles are also congruent, and we will have angle, side, side, angle, side, sorry. If we go in order, it would be this side, this angle, this side, the angle, the side, therefore giving us side, angle, side as a theorem that proves it congruent. Now, can triangles be proven congruent with the information given in the diagram? If so, state the theorem you would use. Now, because of the, I don't know if you guys remember the transversal theorems, these two are parallel, and this is a transversal, therefore 1 and 3 are congruent. Do you guys remember that? Now I'm going to erase it to mark 1 and 3 as congruent. Also, we have 4 and 2. Those two are parallel. Again, alternate interior angles. 4 and 2 would be congruent as well because of the other parallel lines. So we get 1 and 3 is congruent and 4 and 2 is congruent. Now we also know that segment WY is congruent to YW. That's a reflexive theorem. So it's congruent. So we have angle, side, angle. Now, the order, it doesn't matter where you start. You can start from the 2 tick marks to the side to the 1 tick mark for the other angle. And again, angle, side, angle. Example 5. So are these triangles congruent? Explain why or why not. Before we get to a conclusion, we have to realize that these two angles are congruent because they are vertical angles. So we have an angle, side, angle order from the 90 to the side to the angle, the 90, the side, the angle. Now, since that is one of the theorems that we have used, it is congruent by ASA because of these angles that are vertical angles. If it weren't because they're vertical angles, we would not be able to prove that this is congruent, but that because of that vertical angles, we can. So for example 1, it says it's given that angle X is congruent to angle V. I'm going to write down right there. It's also giving us that angle YZW is congruent to YWZ. So these two right here. And they're telling us that XY is congruent to segment VY. So this line right here is congruent to this line right there. Now they want us to prove that triangle XYZ. So this triangle right here is congruent to triangle VYW. So this triangle right here. So I'm going to start writing statement and reason. So for 1, it's always a given, so I'm just going to write angle X is congruent to angle V. Angle YZW is congruent to angle YWZ. Segment XY is congruent to segment VY. Now that is a given. For question 2 or part 2, we can say angle ZY plus angle YWZ. So XZY plus YWZ, which is this one, equals to 180. We can say that that is true because, again, YZW is also, they're congruent, so we can flip-flop them. And I'm also going to say in that step, angle YWV plus angle YWZ equals to 180. I'm going to write LPP. Now I'm going to add a slide on the next part because I'm running out of space. So I'm just going to rewrite it right here, statement. And then reason. I'm not going to rewrite 1 because we have it in the previous slide, so I'm just going to write given. I'm not going to rewrite 2 because we have it in the previous slide. I'm just going to write the reason. For step 3, we're going to substitute the 180. So we're going to get rid of the 180 by substitution. And we're going to say angle XZY plus angle YZW equals angle YWV plus angle YWZ. That is substitution. For step 4, I'm also going to use substitution. I'm going to have to say it again. So I'm going to write angle XZY plus angle YWZ equals angle YWV plus angle YWZ. Again, substitution. For number 5, I'm going to actually use subtraction. So I'm going to get rid of some stuff that I have up there in step 4. So I'm going to get that angle XZY equals angle YWV. So subtraction, POE, property of equality, for you guys who don't remember. And the last step is what we want to prove. Triangle XYZ is congruent to triangle VYW by the angle side. So here we proved that that angle that I mentioned earlier was congruent to each other, angle XZY and angle YWV, by doing substitution twice and by doing the subtraction. So for example 2, we have given that JL bisects angle KLM. So I mean, since it bisects it, these two angles are congruent. And they're telling us K and M are congruent. Now, probably the best reason you guys can say is the angle side. So because you have two angles already, you just have to find the side, which you know it's existent because it's the side that they share. Now you do have to write what I drew. The angle KLJ and angle MLJ are congruent, but that's a definition that you guys should know. I'll give you a minute to start doing it on your own while I write statements and the reasons. I'm going to start writing the given. So JL bisects angle KLM and angle K is congruent to angle M. So that's a given. So for the second step, I'm just going to go ahead and go with the angle I marked. I already marked it, so let's write it down. So we have angle KLJ is congruent to angle MLJ. That is the definition of an angle bisector. Now for step 3, again, I mentioned the easiest would probably be angle side. And again, this is JL equals itself. So I can say JL is congruent to JL. That's the reflexive property. And step 4, we can say that the proof, because we have the angle that's given, the angle we stated, and the side that we stated in that order, we can say that triangle JKL is congruent to triangle JML by the angle side. Just as a reminder, your homework is due tomorrow, but this is it for the notes.